Very pleased to introduce the next speaker, Stein. He's the CTO of RAD Data Communication. And I will just introduce just the beginning of his bio because it's quite big. And he's also lectures at Tel Aviv University and actively participates in the IDF. He co-chairs the TikTok working group and other standardization forums. And he has also authored numerous articles, patents, and standards, and the textbook Digital Signal Processing, a Computer Science Perspective. Thank you for joining, Yakov.
Thank you. I see everyone's walking around here, so I'll do that as well. Hector and Wim really gave me a great lead-in, so I can save some time with some of the things about CPE and maybe reinforce some of the things we were talking about. This whole session is about CPEs today, and I'm going to talk a little bit about the evolving, notice the pun here on next generation CPE. Just to explain where CPE comes from, the concept of the CPE we've been used to for many, many years. It started off as a really, really simple kind of box that sat at the customer premises. But as we've seen, it's been broadened really, really significantly. And a lot of things have become part of this picture of the CPE. And so I want to start by explaining where we were, what happened in the meantime, and what we are now, and where we're going with the idea of the CPE. So, as I said before, at the beginning, CPE was a device which gave us basic demarcation functionality, maybe a little bit of routing at the customer premises. That was really, really great for the kinds of applications we were doing then, which means things like lease line, really simple applications, which were maybe bandwidth and delay kind of things were involved, but nothing more complicated than that. Over time, we've added things like functionality, which makes what we call now rich communication services. In other words, a service is no longer simply get me X amount of bandwidth and with no more than so-and-so delay. I have to have certain functionalities as well. I have to have a firewall and a NAT and load balancing, and all these things are part of the description of the functionality. And a lot of this stuff has been done in POPs or in the data center, but over time we're starting to put this into the CPE, and a lot of functionality is best there. And you've heard me several years already talk about the DNFV picture, where we decide that a functionality doesn't have to be where it was conventionally, but rather we put a functionality where it's best from the point of view of economics, from the point of view of security, from the point of view of performance as the quality of experience would dictate. All these things can be taken into account, and we don't have to be locked into history. We can put functionality wherever it's best to put it. And what happens because of that to the CPE is we have something called the physical CPE, the PCPE, which is a certain minimal amount of functionality. Wim was just talking about this before, that there are things that it doesn't make any sense to move out. For instance, if I have to have a basic OEM to do loopback. Now, what does it mean to take your loopback and put it into the cloud? You can't do that. You have to get to the physical box in order to trace out what's happening. Similarly, let's say, for instance, I want the end-to-end encryption. Now, you can't put end-to-end encryption in your data center. It's got to remain in the box. So certain things have to stay in the conventional location. However, there were certain things which we can move around, and therefore, in addition to the PCPE, we started seeing the UCPE. The UCPE means functionalities that were originally in the cloud, we're moving them into the CPE, as against the other idea of things that were originally in the CPE moving out. So we have this back and forth thing where some functions moved from the CPE to the data center, and some came back again, okay, or came for the first time. So that's evolution we're seeing in the CPE. Now, along with the story of the CPE, there's another story which we've been seeing, we were hearing all the time, the idea of a white box. Now, the problem with the white box, it's just as I'm mentioning in a moment that the CPE has two meanings, white box has two completely different meanings, depending which group you come from. When the SDN people talk about white boxes, they mean a white box, what I call now a white box switch. That means a switch, which I understand exactly what it does, but it's normally a piece of dumb hardware. In other words, it's much simpler than the forwarding devices that we were used to in the past. And it has some kind of interface, let's say OpenFlow or some other dirty word of that kind, which configures it. On the other hand, people talk about white box servers. Now, white box servers means, well, the official name is commercial off-the-shelf, in other words, x86. It means something I can dump on there, and everyone knows, once again, how it works, because it's part of a architecture of computation that everyone knows. Now, I want to introduce an idea we call the silver box, and you see the silver bullet there because it's supposed to solve all the problems, which is based on a white box server, but it can do things that the white box couldn't perhaps do, and I'm really predicating all this on my own experience. I must admit that I heard some of this stuff from, no, there's no problems in time yet, right? Don't look at me that way.
No, no.
There's no problems. I had to predicate that based on what I heard from Dave Ward this morning about what they're doing there. I really want to look at this work. But basically, there's a lot of functionality that right now we can do at high speeds very economically using hardware. And once you move it into x86, it turns out to be much harder and much more expensive to do. So what a lot of people in the NFV world are talking about right now is the idea of adding accelerators. And accelerators can be lots of different things, and that's not the point of this talk, but you just should know that that's happening. Now, when I say I'm moving a functionality into the kind of CPE, virtual CPE, which means not to virtualize the CPE, in other words, take functionality out, but bring functionality in, then you can differentiate two kinds of functionalities. There's the networking kind of functionality and the computational kind of functionality. Does anyone hear ringing? Oh, wait a second. I think it's my telephone. Just a second. No, it's, you know why I got mixed up? This device, and we call it a telephone or a smartphone, but you know, most of the time what I do is I run apps on it. And when it rings, it surprises me. I have to remember that it's a telephone, right? I actually look at my battery usage, and I see that 90% of the battery goes to running apps of different kinds. Oh yeah, and it's also a telephone. Now, the strange thing about that is if you go back a few years, we had this idea of computation, and we had communications, and those were two completely different things. For instance, if you had a computer, what did you do with it? Well, I can tell you what I do with my computer. On my laptop, well, it's over there. I run, solutions of partial differential equation systems and things of that sort, computation. What do most people do with their computers? Well, they use it for Skype, and they use it to download movies, and they use it, well, what are they using it for? Well, they're using it for communications. And my cell phone, which is supposed to be a telephone, a communications device, I use it mostly for computation, for running apps. In other words, we have this thing which we call now computation. It's computation and communications put together. And this line has, in our general day-to-day lives, has disappeared. We no longer see in our day-to-day lives a difference between the two of them. It's all mixed together. Yeah, of course, when we do communication, let's say voice communications, we're doing a lot of algorithms. We always have done things like compression and things of that sort, but we never really had to think about it. Now you have to think about it because it's become so blurred in our daily lives that we don't make a difference between the two of them. But in our professional lives, when we talk about business services, it's two completely different worlds. We have servers that are run by one department, the IT department, and we have, let's say, routers and switches, which is run by a different department. It's acquired in different ways, completely different things. There's a big wall between those two, even though in our daily, regular lives, that wall has disappeared. Now, what I want to claim is that we now have a device, this next generation CPE, which is going to help us in our professional lives blur the distinction between computation and communications. And this is going to be a key element. In other words, we have this next generation CPE, which has both the physical functionality of communications, all the demarcation and forwarding and that kind of stuff, which we always had. But we can also run in it virtualized network functions. In other words, I didn't want to do that. We can run in it different kinds of functions which are giving me networking kinds of things. And we can also run completely computational things in it. And we heard a little bit about that before. So for instance, when I say virtual network functions, I'm talking about, for instance, there was a question just before about IPPBX. We could do an IPPBX, and we can certainly do things like encryption and our SD-WAN and that Hector was talking about. I'll get back to in a moment. But we can also run things that are completely computational. And I'm using some convention here, but we can divide it different ways, the way we want to color it. From my point of view right now, the red, and you'll see it from now on, are the hardware kinds of things, while the blue is the things which are computation-based, but they might be networking functionalities. And when I put the two together, and I have this computation, it's going to be in purple. So remember that as we go on. So let's start from the idea that we were talking about before a lot, DNFV. You've heard this many, many times. In the past, I was talking about, now I say VCPE a lot because it's become the new word to use for that. The idea of the VCPE is that I can put functions which used to be outside into the customer premises when the performance will be better and things of that sort. Okay? Now, the question is, does that box really need to be integrated? Everything I said before, something is best in the customer premises. Why don't I just put a server next to our old CPE? Save a lot of money. You don't have to develop new things. The poor vendors will get out of business, but the customer might like it that way. Well, I want to show you that no, that's not the case. We actually can gain by really making computation happen. In other words, put the computation and the communications in a single box. And I'm going to show you a couple of cases of why that happens. The simplest case is what I call the ships in the night case, where we have the computer and we have the modems, server, whatever it is, one next to each other, and we can get a little bit out of it, but then we can do better than that by having the data planes integrated. And the best story is we're going to have the management planes integrated. So what's the ship in the night case? It simply means I have them together, but they're going to be in one box. They could really be for this kind of scenario in two different boxes. But if I put them in one box, I can benefit from simple things like real estate, having to power them up. Maybe I can do a little bit of things like saving on delay. Don't have to have the cord in between. I can probably do energy efficiency this way if I really work hard on it. And as an example, if you look over here, but the things in red here are the hardware functionalities which I've been doing in typical demarcation devices. I just drew them out so you can look at them carefully. And I put a compute node right in this same box. The compute node, of course, is in blue, if you remember what we were talking about before in the colors. And that way, I get a little bit less delay, a little bit less cost, et cetera. OK, that's simple. Let's go on to the next case. If I integrate them into a single box, then I can do something like put the computation not on the user side of that box or on the network side of that box, but anywhere I want in between with all these functionalities I had before. And there are reasons, for instance, putting the computation between the switching fabric and before all the processing I do before I send it out to the network. Because remember, if I put it on the network side, actually, after I leave my NID, I then have to go through someone else who's going to look at the packet, take it apart, do its own DPI, process, and then do all the recomputation. And let's say I wanted to do policing or shaping. I lost it. But if I do it this way, I get it in a single integrated device. So that's good, but I can do even better than that. Oh, here's another, by the way, I forgot this one. This is a picture which I really like, because if you think about it, once again, the red is the hardware, the blue is the software. Rather than putting the compute node in any particular place, I can actually instantiate a whole bunch of VNFs, and I can now put all of my old hardware functionality and these VNFs, hang them off the switch. So internally in the box, I can do chaining, going up and down and put functions in different places and sort of get now a very, very flexible CPE. And that's without doing anything in the management plane. I just have to know how to do this internal service chaining. I don't want to get into it, but notice I never go back to phi. So I can do it at a really simple level without actually having to do things which are like routing and things of that sort. But the really interesting thing is when I get into the management plane, I want to integrate this so it actually looks from the point of view of management like a single box. Now, in the past, we had two different kinds of management. For instance, if we were talking about virtual functions, we had the NFV orchestration stuff. And we were talking about the pure routing and things. In today's world, we call it SDN. We used to call it NMS, right? But let's talk about SDN mostly. Now, the problem is there are two management systems. One, let's say the SDN one, and one, the orchestration and the Mano and all that kind of stuff. And the question is, how do I get them to go together? Now, I actually had a whole bunch of pictures. I brought them down to 3. But in these last 2 days, yesterday and today, we've heard a lot of other options. So I'll mention a few others that I sort of censored out because I thought they were less interesting. But we actually saw them here today. So the 3 I'm going to talk about, and once again, we're all in the integrated management case, is number 1, if I put the SDN on top of, the SDN controls me on top of the orchestrator. Number 2, the NFV orchestrator is on top of the SDN controller. And number 3, as I unify them, what I call a controller, which is the orchestrator and controller together. Yeah, okay. No, I'm okay. So let's do the easy case first. This is what the ONF would say. If you go to the ONF and say, well, I want to do some NFV, they'll say, no problem, we have an SDN controller. It can tell the orchestrator what to do because, you know, we're the... And there's a lot of good reasons of doing that, don't forget, because the model that the SDN people use is sort of like a software model where we can write applications up on top, and you don't have to recompile your orchestrator to do something new, like in the communications world where the orchestration system is put up by a single vendor. We can put apps on top. It talks to the controller. The controller now, amongst all the other things it talks to, it can talk to the orchestrator and actually the manual system. And then I basically have this integrated box, but I still have to talk to it in two different ways. I still have two different interfaces in, one for the SDN, one for the VNFs. When I say VNFs, I mean both the NFVI kind of thing, the VIM, and the VNFM, right? Or I could do it the other way around. If you went now to Etsy NFVISG and said, okay, how would you do it? They'd say, no, control's not on top. Of course, the orchestrator's up on top, and it talks to the controllers. And actually, yesterday, we all heard Marie-Paula Gaudini showing many different variables around this one. You could put it in lots of different places. So I made it really simple, but you can go into it. And once again, we have an integrated box, but two different management interfaces going in. One running, let's say, a REST interface, one running an OpenFlow or any of the other interfaces that you might happen to like. Karidi, you missed everything. In any case, if I unify them the best way I could unify them, oh, by the way, in between this one and this one is another model, which we actually heard this morning from Telecom Italia, which was talking about like a service orchestrator above an SDN controller and NFV. I skipped that one because I thought it wasn't interesting, but I heard this morning someone says, wow, that's the way of doing it, so remember that one as well. But let's go to the one I want. Oh, that's the one I want to talk. Just 1 second, we're back there. The orc controller. No, it has nothing to do with the Lord of the Rings. It has to do with actually merging together the SDN controller and the Mano in all its parts. I'm not going to go into the details. You can leave the applications up on top like in SDN if you want to free up those applications and you really trust your programmers. And once again, there's a problem with that because if a programmer makes, you get some program right out of university and he doesn't really understand networking, makes a mistake and takes down services of other people, you wouldn't really want that to happen. But let's assume you could do that. But if you don't want to, you want to recompile this and have people who really want to do it, that's fine with me. But the idea is now we have a single southbound interface coming from this unified entity which controls the boxes. I want to, as you already heard from Hector, have you come visit the RAD booth where we're actually showing a single integrated device. This integrated device right now talks to two different kinds of entities above it, one from RAD, one from Versa. Shows you how easily this can be done. It's a really nice demo. I invite everybody to come over to see it, SD-WAN inside of the NFV box. And you'll see the principles we were talking about. And in conclusion, my point was that this next generation CPE, no matter how you really manage it, as long as you manage it in some unified way, becomes the way to blur the distinction in our business lives, just like we already did in our private lives, between communications and computation to make it a computation enabler. And that's the calling of the NG and CPE. Thank you.
Thank you. Thanks a lot. Thanks, Yakov, for this very lively presentation. Also introducing this new animal, the orc controller. And also I realized in slide 3 that you invented the perpetual movement, which is probably the breaking news. More seriously, and as you actually were, I kind of remember you were one, if not the first, to push hard this concept of NGCP and x86 and NFV in the CP and so on. One quick question, what is your view on the evolution of the life cycle of the CPE with this new paradigm? I mean, what will be the refresh cycle of CPE in service provider network? That's
an interesting question. First of all, I'd like to follow on to the part of your question, which was simply, I remember when the NFV started up and we were talking about, yeah, NFV's a great idea, let's do it in the CPE. Everyone said, that's crazy, that's complete idiocy. And we had to work really hard to get in the original white paper one line that said VCP is possible. And now everyone says VCP is the sweet spot of NFV. Yeah, there's VCP and SD-WAN maybe, right? Those are the two things that are really happening. Yes, the point of going over to a flexible platform is to allow this platform actually live for a long time. Now, what's the problem? The computational resource is getting better and better over time. So if you come to our booth, once again, you'll see how we solve that problem. We still have our CPE with the traditional stuff, which doesn't change as much, and we made the computational part as sort of like a plug-in. So if you get a much better CPU coming out, or larger memory, or something of that sort, you simply plug it in, keep your same CPE, it's recognized, the management system understands what's happening, and it goes.
Yeah, my question was probably more on operation side.
Oh, the operational side, that's a whole nother talk. That's next year.
Okay. Thank you very much, Jacob.
Okay,
Thanks a lot.